Hello class, this is Pagos, and today we are going to solve two classic impulse problems. The two equations we are going to need to find the impulse are impulse equals force times change in time, which also is the same as delta P, or change in momentum. So delta P equals P final minus P initial. And we know that momentum equals mass times velocity. So, let's look at the first problem, example 1. A force of 30,000 newtons is exerted for 4 seconds on a 95,000 kilogram mass. Find the impulse. So, the way we're going to solve this is we're going to use the first equation, impulse equals force times time. And so we know that impulse, or the force, is 30,000 newtons times 4 seconds. So we know that the impulse equals 120,000 newton seconds. Okay. Now, another impulse problem you will come across is similar to example 2, which is 6.1a on page 173 in your textbooks, if you want to flip to that now. 6.1 states that a golf ball with a mass of 5.0 times 10 to the negative 2 kilograms is struck with a club, as in figure 6.3. The force of the ball varies from 0 when contact is made up to some maximum value when the ball is maximally deformed, and then back to 0 when the ball leaves the club, as in the graph of force versus time in figure 6.1. Assume that the ball leaves the club face with a velocity of 44 meters per second. Find the magnitude of the impulse due to the collision. So we know that the mass equals 5.0 times 10 to the negative 2 kilograms. And initial velocity equals 0. And final velocity equals 44 meters per second. And this is 0 meters per second. Okay. Now, the equation we're going to use is impulse equals change in momentum, and we know that is P final minus P initial. And we know that impulse equals, because P final is, or momentum is mass times velocity, we know that P final will be mass times velocity final minus mass times velocity initial, and the mass is 5.0 times 10 to the negative 2 kilograms times 44 meters per second times 5.0 times 10 to the negative 2 kilograms times 0. And that shows that the initial momentum is 0, so we can cross it out. And the impulse will now we'll solve for the impulse, and the impulse is 2.2 kilograms times meters per second, or 2.2 Newton seconds. I hope this was helpful. That's all for today. Thank you for watching.